finish up this section on circles. We talked about standard form or center radius form. We have a second way to write out our equation called general form of the equation of the circle. And you'll notice here x squared plus y squared plus ax plus by plus c equals 0, where a, b, and c are all real numbers. Now, this is written this way, but it's very difficult to determine any information about the circle or to come up with its graph unless we can convert this back into standard form. So that's what we're going to practice here. Write the equation of the circle in standard form, then identify the center and the radius. Well, to do this, I'm going to have to use completing the square, and I'm going to have to use it for the x's, and in this problem also for the y's. So I'm going to bring the minus 8x next here to the x squared. I'm going to leave a little space here, plus y squared, and then plus 2y. Now the minus 8, I really don't want here on the left side. So I'm going to add 8 to both sides. I'm not writing it out because I'm a little lazy. I'm going to add 8 to both sides. That's going to get rid of this minus 8. It's going to give me a positive 8 on the right. And what I've done is I've set this up to complete the square for both the x's and the y's. Notice my lead coefficients are 1, which I want. Now, if you remember from completing the square, you take the coefficient of the linear term. In this problem, for the x's, it's negative 8 because of the minus sign. I take half of that, which would be negative 4, and I square that. So negative 8, half of that squared. And that's going to give me positive 16. So I'm going to write a plus 16 here. And of course, if I add 16 to the left side, to keep everything balanced, I have to add 16 to the right side as well. Now I'll do the same thing here with the y's. I take the coefficient of the y, the linear term, which is a positive 2. I take half of that, which is 1, and I square it, which is positive 1. So I'm going to add 1 here. I'm also going to add 1 here to keep everything balanced and equivalent. Now I can rewrite this as this is a perfect square trinomial. This is a perfect square trinomial. I can write it as a binomial squared. I can write this as a binomial squared. And of course on the right side, it looks like I have 25 if I've added those numbers correctly. So this is going to be an x and a 4 and a minus sign. This is going to be a y and a 1 and a plus sign. So that tells me that my center is 4, negative 1. Remember, x minus h, quantity squared, plus y minus k, quantity squared. Okay, and equals r squared. So there's my center, and my radius has length 5. Now, if in the process of changing general form into center radius form, we rewrite it by completing the square, and we get some number over here, c, which I had for this last example is a 25. It's a constant. One of 3 things can happen. Most of the time, c is going to be positive, like in this example, again, positive 25, and the graph turned out to be a circle with radius the square root of 25, which was 5. But if c is 0, then the graph, the radius is 0. If c is 0 here, the radius is 0, and all you have is a single point, which is the center of the circle. So the entire graph of the, quote, trivial circle is just its center. But if c is negative, well, you can't have a negative radius, so we say that the graph does not exist. I don't mind if you write down capital D, capital M, capital E. These last 2 special cases are referred to as the degenerate cases, okay, because you don't get a pure conic section, you don't get a pure, in this case, a circle. So what I want to do here is see what happens if I go through these steps of completing the square and rewrite this into standard form or center radius form, and then see what happens if I get which one of these 3 cases occurs. Now in this problem, I only have to complete the square for the x's, because there is no linear term with the y variable, so I just leave a space. I'll put plus y squared, which is like the quantity y minus 0 quantity squared, and then I'm going to subtract 5 from both sides. I get a negative 5 over here. Now to complete the square, I take half of this number, because my, again, lead coefficient is 1, coefficient of my linear term, positive 2, take half of that, which is positive 1, and then I square it, and so that's a positive 1. So if I add 1 to the left, I have to add 1 to the right. This is a perfect square trinomial and can be written as a binomial squared. this is y squared. Again, y squared, if you wanted to think of it as y minus 0 quantity squared, would fit the form y minus k. K in this case is 0. But on the right side here, I'm going to get a negative 4. This was x and 1 and a plus sign. Well, my value c here is less than 0, so the graph does not exist. So to identify the solution set, there is none. There is not a solution set. The solution set indeed is empty.